Hello everybody, I'm Nick, and today I'm going to show you how you can use the streaming feature of gRPC in .NET. Streaming is the idea of keeping a single connection open where you can send messages back and forth from client to server, and gRPC makes it very easy to use such a feature. Previously, we've only touched upon unary calls, which is the idea of a client asking the server to do something and give something back. So in this video, we're only going to focus on how the server can deal with streaming calls and how it can write back to the client in a real-time way. Such a feature could be great for things like weather data, which is what we are actually gonna touch upon, real-time weather data. But it could also be things like location data, real-time analytics, customer behavior, customer analytics, and also stock market data. All of those real-time ideas could be implemented using gRPC streams. There are some caveats, by the way, and I will talk about them later in the video. But for now, let's just focus on the implementation side of things. And this will only be on the server. In the next video, we're going to talk about how you can do this from the client side. And we'll also include the unary calls. So let's just dive straight into the code. So what I have here is the same weather service from the two previous videos. And the only thing we had is a request for the weather service to get the current weather back. So unary call, client asks, server responds in gRPC fashion with the current weather for a specific city. And the only thing on the profile that you need to do to enable streams is just to add the stream keyword in the return type of your return type, the brackets. So this is literally all you need to do. If I was to rebuild my code, this would generate a streaming method. That being said, I don't want to touch this specific method because you might want to get the code from the description and run this locally, or just use the code from the previous video. So I'm going to make a duplicate method which would return a stream version of this RPC call. And I'm just going to put the stream here. Now, streaming weather, that doesn't really change every second, especially with the free API that I'm using. Won't really give you the idea of real time. So for that purpose, I'm also going to add an extra property in my response, which will be the current timestamp, which will just represent current time that the weather was like this. And we only do this to know that, hey, this is actually really a streaming call. So in order to have a timestamp type, which is not there by default, I will need to import something. And I can do that by using the import keyword and then just saying Google protobuf and timestamp.proto. And this is how in protobuf you import a different type or a different file into your own. So that's also a great example for that. And then to reference it, you just go to the response that you want and you just say google.protobuf.timestamp, and that's your type. In fact, Rider should allow me to go to the item itself and see how it looks like. And this is just how an external protobuf file looks like. And it's mostly comments, maybe because it has examples, yes, but that's just the contract that we will be using. It's a Google protobuf standard file, and we're just going to say that this is the third property in this contract, and that's it. We don't need to do anything else. All we need to do at this time, well, actually we do need to give it a name, so timestamp, but that's all. I'm going to build my solution, and I expect this to create the new code that I need. Let me just make this smaller. So this is what we had in the previous video. And what I'm going to do is update the previous code from the unary call to also set the timestamp. And timestamp is a class, this specific timestamp that Google provides in their gRPC package. And they have a way to load it from datetime and automatically convert it. So we're going to say timestamp.fromDatetime not today, UTC now. You could use datetime offset as well. It depends on what you're trying to do. And with that done, I think I'm going to extract this piece of code because I'm going to need it to get the current weather from the API. So I'm going to say get current temperatures async. And I do not think that I want to, oh no, I do want to do that. So I'm going to extract that out here. Perfect. And now I should be able to override the streaming method that I just added in the protocol buffers. So override get current weather stream. And let me just expand this so you can see it, and let me just say, I'm going to remove this and I'm going to say async, so I don't see this grayed out thing. So what we have now is request, which is the same thing that we had before, and we still have the server called context, which we had before as well, contains information about the connection and the request. But now we also have the response stream, and as you can see, we don't actually have a return type. That's because we wouldn't just return something. We keeping the connection open, and we're constantly returning data. So for this specific purpose, we're going to be writing into that stream, and we're going to do that every second because we want to emulate a service that every second in real time updates you with the current weather. So in order to do that, I'm going to copy this piece of code and paste it here, and then I'm going to have a for loop, and let's just say that we want to do this for 30 seconds. We could have it indefinite as well. We could have an infinite loop here, but for the purposes of this video, I'm just going to do 30 seconds. So 30 iterations and task.delay for 1 second, so asynchronously wait per second. And what I want to do is I'm going to get the current weather in the same way that I do it up here. And now, in order to write to the stream, all you need to do is say response stream.write async, which is basically the only method. And as you can see now, the object that it's expecting is the weather response. And because I'm a programmer and I'm just copy pasting stuff, I'm not really doing anything else, I'm just gonna paste this here. I'll wait the stream, put a semicolon, and that's it. Now I have a real-time streaming method in gRPC. It's that simple. They made it so easy. So all I need to do now is just run this, and like I talked about in the previous video, I'm using a client called Bloom RPC, which doesn't allow me to zoom in the actual operation, so I'm gonna enlarge this during editing. But this, all it needs me to do is provide the protocol buffer file, so weather.proto, I upload it. It detects the two calls, get current weather, which if we were to use should, and that unit represents metric, and if I were to use that, I'm going to get the current weather. As you can see, it's 8 degrees, but I could very much use the streaming approach, and the tool is actually detecting it. I'm going to disable interactive because I want it to be real time in a single window, and all I'm going to do is just run it. And as you can see, the weather doesn't really update because this is a free API that doesn't do high precision temperature updating, but the timestamp is updating, showing that this is a new request, actually a new response per second, and you can see it here in the description as well. And after 30 iterations, this will just stop. What happens if I just press the button to stop it myself? Well, it stopped, but it stopped with an exception because we didn't actually handle the cancellation. You can very easily do that. There's multiple ways actually, but the one you're probably going to be more familiar with is using the cancellation token. So context, like I said before, has all the information for your request and your connection, and there is a cancellation token which you can check whether has been cancellation requested. So you can very much say if cancellation has been requested on the token, and I could just break here, but for visibility purposes, I'm going to just inject a logger and print that it was cancelled manually. So I logger weather service logger and import from the controller, and I'm going to use that logger here and say logger.log information request was cancelled. Yeah, here we go. Cool. So if I run this again, I did not debug, did I? Okay, that's fine. That's the real matter. And if I run the request again, as you can see now, it's running, but if I press the big red button to stop it, now we are logging that request was cancelled. So it goes in here and we're breaking out of the loop. And that's basically, that's how you can do real-time streaming in gRPC in .NET. Now, there are a few caveats in doing such a thing. Keep in mind that this is an open connection, that if you're doing any local testing should work absolutely fine with any issues. But if you are to push this in production, you have to keep in mind that traffic managers, reverse proxies, or any type of proxy will actually potentially interfere with this type of connection and might drop it. So it's up to you to re-establish this client-server streaming communication, which could be an issue where you need to code around that. And something else that you need to be aware of is that if there's long periods of inactivity, you should be sending keep alive pings from the client to the server, so the server and the hosting and the traffic manager is aware that, yeah, this is actually still alive. Don't drop this connection, we need it. So there are a few caveats there. The other thing is that this write async method isn't thread safe. So any sort of multi-threading on that specific stream could actually cause issues. However, you can get around that by using something like channels to marshal the messages and have a consumer producer sort of situation. But you again have to code that. It's not built in the framework itself. So you have to be very cautious using this. And the last thing, which is probably the most important thing, is that if you're just doing regular unary calls and you think that this will speed up your operations, then you should only use that feature when you have identified that gRPC and HTTP2 are actually the bottlenecks themselves and nothing else is stopping you from scaling any further. So these are a few things that you really have to be careful when using such a feature. That's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you're going to find a link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.